Okay, so here we're told that air is pumped into a spherical balloon at 100 cubic centimeters per second. How fast is the radius changing when the diameter of that spherical balloon is 50 centimeters? So air is pumped into a balloon at this rate. It's a balloon, we're talking about volume, that's why it's cubic feet per second. So we're talking about the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. So I'm just writing down the formula for a sphere because we'll probably need to use that since we're given the rate at which the volume is changing, which is 100. So that's the rate air is pumped in, so that is the rate at which the volume is changing, and we're told that it is 100 cubic centimeters per second. How fast is the radius changing? So we want to find dr dt when d, because everything is in terms of r here, I'm not going to write d as 50, I'm going to write r as 25. Because the radius is half the diameter, and our functions have r and not d. So we know what the rate at which the volume is changing, so let's take the time derivative of both sides of this. So when we take the time derivative, we get dv dt equals 4/3 pi. The derivative of r cubed is 3r squared times the derivative of r, but the derivative of r with respect to time is dr dt. Now we plug in what we're given. dv dt is 100 cubic centimeters per second equals this 3 cancels with that 3, so we get 4 pi times r squared, but r is 25 centimeters, so we get 25 centimeters squared times dr dt. dr dt is what we're asked to find, so we just divide this. So we have 100 cubic centimeters per second, and we're dividing that. I'm going to leave this in factored form. 4 times pi times 25 times 25 times square centimeters. That's what dr dt is. Now, centimeters cubed over centimeters squared give us units of centimeters per second. So that's how our units cancel. 25 times 4 is 100, so that cancels, and we're left with 1 over 25 pi. So that's the answer. That is the rate at which the radius is changing for when of a spherical balloon when air is pumped at this rate and the radius is 25 centimeters.